Dear friends, in this video, we will look at another problem in the context of decision making using hypothesis testing procedure in a step-by-step manner. This is dealing with a situation of new product launch decision. Let's look at the decision problem. Should the new product be introduced or not? Should the new product be launched or not? Both are same. Let's look at the problem. A marketing manager of an enterprise is facing a decision whether to introduce a new product into the market or not. Consumer acceptance measured in a blind comparison test is agreed upon as an appropriate basis for evaluation. Marketing of the new product will be pursued only if the acceptance rate exceeds 30%. Otherwise, the new product will not be introduced in the market. A random sample of 200 consumers reveals that the acceptance rate is 32%. Should the new product be introduced? Use 5% significance level for the procedure. It's a very interesting problem. If you look at the problem, what the problem wants is 30% acceptance rate in the market as a whole, or population acceptance rate as 30%. We have a sample acceptance rate based on a sample of size 200 as 32%. So at the tip of the iceberg, you are tempted to conclude perhaps the new product be introduced because 32% is better than 30% or is greater than 30%, and 30% is the threshold value that is set for the introduction of the new product. So let's do the procedure in a step-by-step manner. Formulate the null and the alternative hypothesis. H0, the null hypothesis, population proportion capital P equal to 0.3. HA, the alternative, population proportion capital P greater than 0.3. We are using capital P for the population proportion and small p for the sample proportion. This is the first step. So if you accept the alternative, then you can introduce the product. If you accept the null, then you cannot jump the gun and introduce the new product. So let us see what happens as we go along. Step 2, select the appropriate test statistic. In this case, Z-stat is equal to small p minus capital P divided by square root of P, capital P, into 1 minus capital P upon n. So, under the null hypothesis being true, we may have to compute this particular expression, which is called the test of proportion using the Z-stat. Let us see the third step now. Compute the Z-stat under the assumption H0, the null hypothesis, being true. So Z-stat equal to sample proportion is 0.32, population proportion, which is the hypothesis parameter value 0.3, which we subtract, square root of 0.3 into 1 minus 0.3 upon 200. When you simplify, you get 0.62 as the final value rounded to 2 decimal places. The fourth step is draw the diagram and mark the Z-stat value. All of us know Z follows a normal distribution with mean 0 and standard deviation 1. The Z stat value which we have calculated in the previous step is 0.62. So we mark it here 0.62. So anything more than 0.62 till the end will be the p-value. So the fourth step involves just marking the Z stat in the diagram. Let's now look at the fifth step. But before we look at the fifth step, how do you calculate the p-value, which is shown here in the fifth step, p-value equal to 0.2676. Let me just take you to Excel as before and show you the calculations here. Let's look at this cell here, D2, and I compute the function norm dot s dot dist, which is the standardized normal distribution probability value for a given ordinate. In this case, it is 0.62, no doubt. But as you can see in the diagram, this 0.62 is the right of that. Excel gives the cumulative up to 0.62. And therefore, what we need to do, whenever the ordinate is in the right of that, we must subtract from 1 the cumulative probability. If it is left, it is straightforward. So what we do now here is go back to Excel and put in front of it 1 minus norm.s.dist 0.62, and it's a cumulative probability we want, and therefore we put the bracket, enter 4 decimal places. The value is 0.2676, which is the p-value shown in the PowerPoint slide, as you can see, ladies and gentlemen. 0.2676 is the p-value. So let me show it to you again. So the fifth step, compute the p-value based on Z stat. Probability of Z greater than 0.62 appears as 0.2676. In other words, the actual risk is 26.76% of committing type 1 error. In other words, rejecting the null hypothesis when it is true is 26.76% of the time. Whereas the alpha which is specified is that desired risk is 5%. So let's go to the sixth step, which is the final step. If the p-value is less than alpha, reject the null hypothesis, else accept the null. When you reject the null, you will accept the alternative. And let us see what happens in this situation. Since the p-value 0.2676, sorry, there is a typo here, it is 0.2676 actually, which is to the 4th decimal place, is greater than alpha 0.05, accept the null hypothesis for want of evidence. That means, indeed, the marketing manager does not have the requisite support to introduce a new product, as the p-value is 0.2676. And therefore, what you are saying is you are approximately 73% confident, whereas what you want is 95% confident level. The actual risk is 26.76%. The desired risk is just 5%. Therefore, do not jump the gun and be adventurous. If you still want to introduce the new product, you must recognize the fact that your actual risk or the committing probability of type 1 error is 0.2676. And therefore, the final conclusion is, if you specify the desired risk as 5%, please do not introduce the new product. You do not have the requisite support. Therefore, accept the null hypothesis and conclude, wait for some more time, improve your campaign, sales campaign, and test it again with the same blindfold comparison test after some time, and then find out whether you get the desired alpha 5% or your p-value is greater than less than 5%, then only you can introduce. And therefore, in this case, it is very straightforward. Do not introduce the new product as you do not have the requisite support. Thank you very much. I hope you have gained some knowledge, and let us see you soon in another video.